Good afternoon, boys and girls. Welcome to today's lesson. Today we're going to be looking at this lesson, how to construct an irregular polygon. Here is the exercise. You can see this exercise was sent to you. So I'm going to be demonstrating how to construct 1, 2, and 3. You will construct all 3, upload as a single PDF document on Plus Portal on Friday of this week. All right. To begin this construction, you'll need a few tools. Of course, you'll need your set square. That's a 45 by 45 degree set square. Your 60-30 degree set square. You'll definitely need a compass. You'll also need your T-square. Of course, you'll need pencil. You might also need an eraser. At the end of the lesson, you will be able to produce 3 nice, accurate drawings like this. So let's get right into it then. Our first task is to construct a irregular polygon given the length of the sides. The sides given are ABCD, AB equals 50, BC equals 70, and CD equals 70 as well. On the last side, AD is equal to 50. The angle at B is 120 degrees. So let's get right into it. The first thing we're going to do is to draw the baseline AB equal to the given measurement of 50 millimeters. So I'm going to use my T-square and draw my horizontal line, call this A, B, and this is of course 50 millimeters. 50 millimeters. All right. The next step we're going to do is to draw the angle at B, and it must have a length of 70 to C. Now, angle on a straight line is equal to 180 degrees. Therefore, if the included angle here is 120 degrees, it means the sum of the two angles must equal to 180 degrees. Therefore, the angle here, the missing angle, is 60 degrees. The implication for that is, if I use my 60-30 degree angle, so I'm going to use my 60-30 degree set square and draw a line at 60 degrees. The opposite side of the line is going to be 120 degrees. So you could use your 30-60 degree set square for this, or you could use your protractor to measure the angle. If you do not have a set square in your possession, you could actually use your protractor right here, okay? Now, extend the line at B for 70 millimeters, and this will produce point C. Once again, the angle here at B is 120 degrees. The opposite side is 60. The sum of the two should equal to 180. Now we would have gotten two sides of the irregular polygon. We need to get the other two sides. We are told from the information that CB is equal to 70, and we also see where DC is also equal to 70. Since we would have gotten BC equal to 70, we can transfer this measurement to get CD. You could use your divider. I'll choose to use my protractor in this case, my compass. So take off the length of BC, which is also equal to CD. So with center at C, draw a light arc. Now anywhere on this arc from C will be 70 millimeters. We have one side to get now, and that's the last side. That side is AD. We no longer need this, so I'll take this out the way. But we have seen also where AD is 50 and AD is also equal to AB. Therefore, take off the length of AB, which is the same as AD. And thus we would have produced the point here for D. So now we would have produced all 4 points that are required, A, B, C, and D. I'm now going to darken these lines with my rule. Nice, straight, dark lines. It goes. And this is number 1, our first question. Now let's move on to number 2. The second example on this particular assignment is an irregular pentagon. We are given the length of 5 sides, but this time we are given the sides of 2 angles, angle F and angle G. So let's get right into it. We're going to draw the base EF equal 40 millimeters. Base EF, draw a line equal to 40, and we're going to call this EF. And of course, this baseline is going to be equal to 40 mm. Okay? Now the angle at F is 135. In the previous example, we demonstrated how we use the set square to draw an angle of 120. Now, a set square could also be used to draw an angle of 135 degrees. If I have my 45 degree set square here, 90 plus 45 is equal to 135. The implication for this is, if I use my 45 degree set square and draw an angle of 45 degrees from F, this side over here will be 45 degrees. We are told, and we know that angle on a straight line is equal to 180 degrees. Therefore, the opposite side of the angle must equal to 135 degrees. So this is one easy method that can be used to draw your angle of 135 degrees. Now, if you do not have your 45 degree set square, you could also use, once again, you could use your protractor to do it. And your rule. In your geometry set, you have these basic tools that could be used. All right. So we would have gotten EF is given as 40. And from F to G, we're also told that that is 40 millimeters. So you go right ahead and measure 40 millimeters. I'll just use my compass here to transfer the measurement to make sure that I have 40 millimeters for both points. So at this point, I'm going to call this G. Now, if you look carefully at the question, you will see that the angle at G is also 135 degrees. What are we going to do? How are we going to get this? Yes, we could use our protractor to get an angle of 135 degrees. This angle must be 135 degrees. But also, by common sense and by calculation, we know that if this angle is at 45 degrees, it will hit a vertical line which is 90 degrees. So this entire line coming down now will represent a straight line. The smaller side of the angle is 45 degrees. So obviously, the opposite side is 135 degrees. So this is an easy way of obtaining my 135 degrees. A vertical line to the end of point G will produce my angle of 135 degrees again. All right? So from G, we need to get H. But we're told that GH measures 30 millimeters. GH measure 30 millimeters. Once again, EF 40, FG 40 as well. And from G to H is 30 millimeters. So we are striving to get an irregular pentagon. It will have 5 sides. So far, we would have gotten 3 sides, EF, FG, and GH. So we need to get 2 other sides. Here goes. From the information given, we are also told that HJ is equal to 60 and EF is equal to 40. So we have 3 sides measuring 40 millimeters. Since we would have already taken off this length that is 40, an arc anywhere here, anywhere from point E to that arc will be 40 millimeters as well. So we just need one last measurement to complete number 3, and that is a measurement for JH or HJ that is equal to 60. So I'm going to open my compass to 60 with center at H. My compass is now at 60 with center at H, and my radius equal to HJ. I'm now going to swing an arc to cut my initial 40 millimeter arc. This is irrelevant, I no longer need this. Where the 2 arcs intersect will produce the point for J. And we could call this, go right ahead and call this J. I'm going to now use my rule to connect the lines, nice, straight, dark lines, outline, and make sure the corners are sharp to represent my figure that I intended initially. Here goes, nice straight line. And also from J to E. And since you will be using your pencil, these initially would have been in construction, so you're going to just go back over them and make sure the lines are nice and dark and presentable. Very neat. Ensure the corners are very sharp and do not overlap. Also be sure that the angles and your measurement is correct. In technical drawing, measurement and precision is very, very important. So this is the procedure for number 2. Once again, let's recap. Initially, draw the baseline AF, EF equal 40. Draw your 130-degree angle, 135-degree angle. You could use your protractor, or you could use your 60-degree set square, right? Sorry, you could use your 45-degree set square for that. Get the other angle at 135 and use the measurement. Join the lines with nice clean lines, and that will be the figure for number 2. The final one in this week's lesson is also an irregular pentagon that's a little bit more complex, but basically the principle is the same. Once again, we're going to start with the basic principle that I've demonstrated for the previous 2. We're going to draw the base KL equal to 50 millimeters. Start with your light construction pencil, base, and KL, that is equal to 50. Base, KL equal to 50 millimeters. I'll just write 50 there to remind us. This side is K, that side is L. The angle at L is 135 degrees. From the previous demonstration we did, an angle of 135 can be had by using a 45-degree set square. Now, that is going to take us to M. So LM is actually 40 millimeters. So this will need to be extended a little bit more to 40. This will give us point M. So right at L, our angle here is 135 degrees. It's similar to the previous demonstration that was done with number 2. On the opposite side of K, we have 100 degrees. 100 degrees? No, the set square will not be able to use that. So definitely we'll have to go to our protractor. Make sure the center of your protractor is at K. And then you're going to start from 0 and count 0, 10, 20, 30, 40, 50, 90, which is the vertical line on the opposite side of the 90. Make a little mark that would indicate 100 degree. Of course, the length of that is 50. So we'll have to extend this line. We're not sure what the length of that line is as yet. I just estimate that to be 50. But since we would have already measured the baseline, which is also 50, we can now use our compass, take the length of KL, which was measured and drawn at 50, and transfer that measurement to KO. So my estimation here was almost correct. I just need to add just a little bit more to it to make it 50. So this is now point O, and KO is equal to, you get it right, 50 millimeters, all right? You do not have to write the measurement here as there is an approved method for dimensioning, and dimensioning will be taught in a subsequent lesson. Right now, we just want to ensure that it is accurate and that all the angles and the sides have the measurement that are indicated. Now, from the demonstration given, we see where M and O is in one plane, it's a straight line, and here we're going to apply a principle that was learned earlier in circles. M and O is a straight line. This line must be a light construction line as it is not a part of the joint. It's actually only used for construction. Now point N, MN is going to be 50 millimeters, and there is no measurement given for NO, but we're told that the angle that is formed between ON and NM is 90 degrees. This is given on the example on the handout that is sent to you. So you're told that it is 90 degrees. So we're also from previous lesson, we were taught that angle in a semicircle, angles in a semicircle is equal to 90 degrees. So if I draw a semicircle here, draw the side MN to touch that semicircle where MN hit the semicircle will connect it to O. The mere fact that it is in a semicircle, the angle formed here will be 90 degrees. But in order to draw the semicircle, we'll first need to find the center of it, right? So in order to find the center of OM, I'm going to do a procedure, employ a procedure we would have learned earlier, and that is how to bisect a line. So to bisect a line, we're now going to bisect the line OM. And to bisect, we simply mean we're going to cut the line in half. So we're going to find the center of the line geometrically. So with center at O and the radius of your compass just more than a half, it must be more than a half the line, you can estimate that. We're going to swing two arcs on either side of the line, one to the top, one to the bottom. Do not change this radius. Go over to the other side of the line, and then we are going to cut the previous arcs drawn. Cut it right there, and also to the bottom right there, like that. There you go. Where the two arcs intersect, a line through the intersection will represent the bisection and the center for the semicircle. Let's try it. So a line right through here is the center. Now we would have gotten the center for the line OM. We need to draw our semicircle. We draw the semicircle with center in the middle that we just found. Open to O, RM. Not ORM, just O. Can be M or O, which should be the same because it is in the middle. And draw a semicircle. Here goes. There you go. We're almost done here. So we're told, and we were given the measurement for MN equal 50. But from previous measurement, we drew the baseline KL equal to 50. Therefore, we could transfer this 50 millimeters to M. And that's a point. Recall that we have learned earlier that angle in a semicircle is equal to 90 degrees. What this means, two lines from O and M joining anywhere in this semicircle, coming from the same point, O and M, and touching the circumference of the semicircle will be a 90 degree. This is the point we're going to use for N. Why that point? Because we're told that NM is 50 millimeters. All right, so here goes. Join N to M, and we're almost done. One more line to go, and N to O. So this is our irregular pentagon. And of course, you're going to darken K, L, M, and O with nice, straight lines. Avoid double line. Avoid the corner being misaligned or overlapping. Make sure the lines are nice and neat, all have the same weight, all have the same thickness. And this is our irregular pentagon. So this would have concluded today's lesson. And once again, let's recap what we were required to do. Initially, we start out to obtain 3 irregular polygon, number 1, number 2, number 3, from this exercise that is given. All right, so I'll zoom right in so you could see the measurement and you could see the activity that was sent for this particular lesson. Okay. Thank you very much, and that will do it for today's lesson.